We have a Technics SX PR53 piano here, and still plays nice, but unfortunately the sustain pedal previously broke, and we moved the soft pedal over to act as a sustain pedal, but now, as you can see, the pedal is starting to become a little bit loose here, and unfortunately we can't buy parts for this piano anymore. So what we're going to do is see if we can build a backup pedal just as a risk mitigation measure, just in case this one does go. So we're going to look into the pedal design to see if that can be done. These pedals are usually operate in two different mechanisms. One is either a switch on or off, so that'll just activate a switch inside the pedal assembly here. The other way that these pedals could be designed is with the variable resistor or a potentiometer that basically just adds a little bit of resistance as you press down on the pedal itself. So we need to figure out what kind of design we have here to see if we can build a pedal that will function for this piano. Alright, so the connector for the pedal is just at the back of the piano here, just underneath. So we're just going to gently disconnect that. And it looks like the connector is just a mini 4-pin DIN. Okay, so we're going to do a test with the pedal up. So we have a continuity setting on our multimeter. Top left, no continuity. Bottom right, continuity, short to ground. Bottom top right, no continuity. Bottom right, we have a short to ground. Now we're going to switch over to ohms and measure the resistance with the pedal up. Open circuit in the top left, 1 ohm, bottom right, open circuit on the top right, and 1 ohm on the bottom left. Okay, so we have the pedal depressed and our multimeter set to ohms, so we're just going to do some readings. Top left hand pin is 4.7K, bottom left we got a short, 1 ohm, top right, open circuit, bottom right is 4.7K. Okay, the pedal depressed, continuity test. Continuity on the bottom left pin, and nothing on the other three. Alright, so I did a quick search to see if I can find the connector for the Technics piano pedal. And they do have a mini DIN 4-pin on DigiKey. That's what I use mostly for sourcing my electronic parts. So it has all the right dimensions, the specs as per the spec sheet here. And so the part number is CP-2040-ND if you want to order one, and they're only about $3 each. So that's what I'm going to order. Alright, I just went onto Amazon and found this universal piano sustain pedal. It's a Sirocco with a 1/4-inch jack, but that's okay because we'll be replacing that with our 4-pin mini DIN. So it's $22, and I'll go ahead and order that. Okay, our sustain pedal arrived today. So what we want to do now is take some measurements to see how this one is currently configured. We want to basically make sure that it's wired the same way as the one that we currently have. So if you remember correctly, what we're hoping for is a closed circuit when the pedal is not pressed, and when the pedal is depressed we want to have a 4.7K kilo ohm resistance. Alright, so we have our ground here, common, hooked up to the sleeve. That's the ground wire. On a 1/4-inch jack is the sleeve, and the tip is your hot signal. So we have the lead hooked up to the top, to the tip there, and we're just going to press the pedal down. So this one is actually wired in reverse. So when we press the switch down, it's essentially a switch, looks like. So luckily this pedal actually comes with a reverse polarity switch. So there we go. So now we can actually have it connected and closed when the switch is up, and when we press the pedal down we can shut it off. So now we're just going to need to measure the resistance to see what happens when the pedal is depressed. Okay, so we switched our meter to ohms, and we have the pedal not pressed, and we're getting a few ohms there, so that's basically just a closed circuit. So now what we want to do is depress the pedal and see if we get a resistance, and no, we don't. So basically this is just a switch. It's basically a closed circuit, open circuit. So there's no resistance, no 4.7k ohm resistance like the Technics piano has. So it'll probably work. My guess is any sort of resistance, even if it's infinite, will probably add sustain to the pedal. But let's just make it the same. So we're gonna open this up and add a 4.7k ohm resistor into the circuit so that we get the exact same behavior as our current piano. All right, so we want to disassemble it so we can change the circuit a bit here. So what we're gonna do is tear these middle pads off. And if we pop those off, that's what it looks like. There's a little Phillips screw inside here. So we're just going to unscrew this one, and we should be able to pop this apart. All right, the screws are off. So it looks like this just pulls forward and back, and then we can get access to the inside. All right, looks like there's just a spring mechanism here with a switch and the polarity switch here. So this is a polarity switch, and then the circuit switch here. All right, I already had some 4.7k ohm resistors from another project, so I'm just going to solder one of those in line with the circuit when the pedal is pressed. Okay, I analyzed the circuit for a little bit, and I can understand how it works now. So basically, as you recall, we want the circuit to be closed when the foot pedal is not being used. That's the behavior that currently exists. So when the pedal is pressed down, we want to fill up 4.7 kilo ohm resistance. So again, we want the circuit to be closed, but just with the 4.7 kilo ohm resistor. So what we're going to do is if we jump the red pin and the black pin here on this reverse polarity switch, we'll get that exact behavior. Essentially, we'll be able to close the circuit with a 4.7 kilo ohm resistor if we jump those two. So I'm just going to solder the resistor between the middle pin and the far pin with the red wire coming to it. All right, before I solder this resistor in place, I'm just going to add a little bit of flux to the contact points there. That just helps make for a bit of a stronger connection with the solder joint. Okay, so we have our 4.7k resistor in place. So we're just going to give it a quick test. So when the pedal's up, we basically want to have a short, closed circuit, just a couple ohms there, and when we actually press the pedal down, we want to see 4.7k. Looks good. All right, lift the pedal up, we're looking good. Okay, so we can close this pedal back up. So we'll just slide the pedal up underneath, around. Looks good. Close this back up. All right, so we're just going to screw that back together, and then we can work on the new end connector. All right, so the next thing we're going to do is replace the 1/4 inch jack connection with the 4-pin DIN. So we're just going to go ahead and cut the end off here. All right, so I just drew out the circuit that we're trying to replicate based on the testing we did. So if we remember correctly, pin 1, this one here was always tied to ground, whether the pedal was up or down. The middle pedal, which was pin 2, was always open, it wasn't connected to anything. And the sustain pedal, pin 3, was switched, and it was always tied to ground when the pedal was up, and it went through a 4.7k resistor when the pedal was down. Alright, so disassembling this mini DIN is pretty straightforward. You just pull the top part off here, and then this splits in two. Okay, and then we can get access. I think this splits in two as well. We get access to the pins inside here. Alright, so there are the pins. So we're just going to solder our hot wire to pin 3 there, and our ground wire to the shield. Okay, before we do any soldering, what we need to do is just put this plastic cover, slide it through here down the wire first, because it's going to come back up and kind of close everything back up once the connections are all soldered in place. Alright, it's a little bit difficult to see, but this is what it looks like when it's all done. So we have our hot wire, the red one, going to pin 3. We have the black wire going to the case. We have pin 1 permanently grounded. That's our white wire there. And pins 2 and 4 are open, not connected. Okay, so we're just going to run a couple quick tests here. So we want to make sure that pins 2 and 4 are both grounded when the pedal's up. And pins 3 and 4 are open. Okay, good. Okay, with the pedal down now, we want to make sure that only pin 2 is grounded. Pin 4 is no longer grounded. Now we're going to switch our multimeter to ohms and make sure that when the pedal is down, we have 4.7K, and when the pedal is up, we're back to a few ohms. Okay, looks good. Okay, we're ready to test our new pedal. So first thing we're going to do is unplug the old one. Simple as that. We have our new pedal there. There's our new connector. We're just going to line the center pin up here to the back. Plug that in, and we'll give it a shot.
Beautiful.